Okay, hi AP Chemistry class, it's Mr. Mellinger, and we're doing our assignment that was you've had for a few days. It's due on Tuesday, September the 3rd, so let's change the due date here. It's due on Tuesday, September 3rd. Okay, so this is the one you're doing over the weekend. All right, so what we're doing on this assignment is we're constructing diagrams of atoms, learning how to read the periodic table, and then we're also doing some significant figures in the second part. Okay, so let's get started. What you should have is a periodic table. If you don't have one at home with you, you can always bring one up online and just keep it in the background and pull it up when you need it. It should ideally have four things. It should have an atomic number, an element symbol, the name, and the atomic mass. Okay, so let's go ahead and get started. We're going to do oxygen. Oxygen has symbol O, and we want to know, first of all, how many protons. So the number of protons is the atomic number. That's what defines oxygen as being oxygen, is it has 8 protons. Oxygen atom can have a different number of electrons or a different number of neutrons and still be oxygen, but it must have 8 protons. Okay, so we're going to put that on our scoreboard as 8. And if oxygen is electrically neutral, these are positive charges, it must also have 8 negative charges. And so that is how many electrons it also has. And that will always be the case on this exercise. Let's go ahead and draw the nucleus. I draw it as a rectangle so as not to confuse it with the orbitals. So you can do a little better on the focus there. Okay, so we've got protons up here and neutrons here. And we have 8 protons, and now we're going to figure out how many neutrons we have. So what we have to do then is come over here and look at the atomic mass. Now for oxygen, the atomic mass is 16. Let's remember what that means. It's the weight of oxygen. It's how much an oxygen atom weighs, and it's measured in atomic mass units. And although there's a formal definition for an atomic mass unit, we use the informal definition. It is simply the mass of a single proton or a single neutron. You take your pick. So we're assuming those two have the same mass or weight. So if the mass of oxygen is 16, each proton and each neutron has a mass of 1, then this number also tells us how many total protons and neutrons we have. We have an atomic mass of 16. We must have some combination of 16 protons and neutrons. We might not right now be sure which is which or how many of each, although we do know we have 8 protons, but we're going to, in the next step, figure out how many neutrons that we have. So we have a total of 6 protons and neutrons. So that is called the mass number as opposed to the atomic mass. So the mass number, you take the atomic mass and you round it to the nearest whole number. Well, for oxygen, it's already a whole number. It's 16. So the mass number is protons plus neutrons, and that is 16. Now we're going to take the atomic mass, which is the number of protons, and that's just protons. And there's 8 of those in oxygen. And we're going to subtract that. So if we know we have 16 protons and neutrons, and 8 of them are protons, then that means the other 8 have to be neutrons. So we can go ahead and put that there, put it in our scoreboard, and go ahead and put it in our nucleus. Rather than drawing all these circles with plus signs and equal signs, we'll just write it like that. All right, next is orbitals. The number of orbitals an element has is determined by what row it's in. So hydrogen and helium are in the first row. They have 1 orbital, and that's it. Everything in the second row, from lithium all the way over to neon, has 2 orbitals. So we're going to go ahead and draw. We'll write it on our scoreboard, and then we're going to draw it. Just 2 concentric circles. All right. And that takes care of that. Now, how about valence electrons? So valence electrons, valence means outer shell. And that's a very important term and a very important concept, because it's the valence electrons in chemistry that do the chemical bonding. So that's where the action is when it comes to chemical bonding and chemistry in general, is in valence electrons. So how many valence electrons does oxygen have? And the way you tell that is you count how many positions from the left is the element that you're interested in this case, oxygen. So lithium is 1, 2, boron is 3, carbon is 4, nitrogen 5, oxygen is 6. That means that oxygen has 6 electrons in its outermost shell, 6 valence electrons. Okay, now we're ready to go ahead and place the electrons. We know we have 8 of them in all. 2 of them go in the first orbital. And since there's only 2 elements in the first row, that fills up the first orbital. You can't put more than 2 electrons in the first orbital. That means we have 6 left, and those are our valence electrons. The way I ask you to draw them, and you'll see why very shortly, is you put 1 here, and then you spread them out. You walk into a theater, a movie theater, and there's some people sitting there that you don't know. You generally don't sit next to people you don't know. You want to space out. But once the theater starts to get crowded, then you have to start putting them sitting next to other people. So we're going to pair up these 2 once we get to the 5th one, the 6th one, and that are our valence electrons. So you have 2 pairs here, 2 sets of paired electrons, and you have 2 electrons that are unpaired. And those are the ones that can bond. That's why it's important that you show the pairing, where there's pairing and where there's not pairing. All right, so that takes care of oxygen. We're going to go ahead and move down to neon. Element symbol Ne, also called atomic symbol Ne. And we're going to find it on our periodic table. And there it is at the end of the second row. So it has an atomic number of 10. And it has a mass number, an atomic mass of 20.18. We're going to round that down to 20 for a mass number. Okay, so let's go ahead and write that down. So the atomic number is 10. So that means it has 10 protons. And being electrically neutral, it has 10 electrons. We're going to draw our nucleus here. So you have protons. You have neutrons. Okay, so protons is 10. And now we have to figure out neutrons. So we saw that the atomic mass was 20.18. And you round that down, since that's a 1, you round it down to 20. So our mass number is 20. So over here, we're going to write mass number. And let's write down again what that is. It's the protons, total number of protons plus neutrons in the nucleus. And in this case, that's 20. Okay, now we want the atomic mass. The atomic number. Check that. The atomic number. And that is the 10 that's at the top. So we're going to put a 10 there. That's the number of protons. So this is protons. So if we take the protons and neutrons and subtract out the protons, we're left with only the number of neutrons. And that is 10. Okay, so that we're going to go ahead and put that in the scoreboard. Go ahead and put that in the nucleus. And we've taken care of the 3 subatomic particles there. Okay, orbitals. So just as with the case of oxygen, neon we see is in the second row. That means it has 2 orbitals. So we draw those around like this. And we'll put that in the scoreboard as well. Now, valence electrons. Before we place them, let's figure out how many, because sometimes that's all you want to know about an atom is the number of valence electrons. So you want to know how to look at the periodic table and tell that. And what you do is you see how many positions from the left-hand side of the periodic table the element is. So lithium is 1, beryllium is 2, boron is 3, carbon is 4, nitrogen 5, oxygen 6, fluorine 7, and neon is in the 8th position. So that means it's going to have 8 valence electrons. And since it is at the end of the second row, those 8 electrons are going to fill up the second orbital. So the second orbital can hold up to 8 electrons. And so let's place them the way that I showed you. First of all, we got to put the first orbital in, and it can hold 2 electrons, and now it's full. So now we go to the second orbital. We're going to put the first one here. Again, as we talked about in class, a number of you were taught a different way to write these, but you'll see very shortly why I have you do it this way. So space them out, and now once you get to the fifth one, you have to pair them up. There's 5, there's 6, there's 7, and there's 8. So now we have 2 full orbitals. The first and second are both full. That means the next element, which is down on the third row, is going to have a third orbital, and we're going to have to start with a new orbital down there. But this takes care of neon. Okay, let's continue with aluminum. Al, find that on your periodic table. There it is. We see it's down in the third row. It has an atomic number of 13 and an atomic mass of 26.98. So you can see that's going to round up to 27. All right, so let's go ahead and we have 26.98. That's the atomic mass. The mass number is 27. Okay, and we just saw that the atomic number is 13, so it's going to have 13 protons. Let me slide that up a little. 13 protons and 13 electrons. So let's draw our nucleus here. Now we have to do our calculation, our little subtraction problem for neutrons. And we subtract from that the atomic number, which is just the number of protons. We see it's 13. And that gives us 14 neutrons. You see, this is the first element we've dealt with that has a different number of protons and neutrons. They aren't always the same, but for the smaller elements in particular, they're usually pretty close. Okay. So we have 14 neutrons. We go ahead and put that in the nucleus. So now our nucleus is filled up. All right. Now what we're going to do is orbitals. So aluminum, we said already, was in the third row. 1, 2, 3. And I'm going to draw 3 orbitals. There's 1. There's 2. And I didn't leave myself a lot of space there. But there's the third one. That's okay. We'll make do with that, okay? All right, so 3 orbitals because of the third row. Now let's count how many positions it is from the left side. You start with sodium is 1, magnesium is 2, aluminum is 3. So that means aluminum has 3 valence electrons or electrons in its outer orbital. So we're going to put that there, and I should also put that there for orbital. So we filled out the scoreboard. So if you have a third orbital, you necessarily must have filled up the first and the second. So we can just do this a little quicker, minus, minus, and you can just go ahead and not do it necessarily in the order I showed you for the second orbital because you know it's going to be full. So you know it's going to have 8 all the way around. Okay, so there's 8 for the second orbital, 2 for the first, 8 for the second. Now the 3 in the valence, we're going to do it properly. We're going to put 1 there. We're going to put 1 there, and we're going to put 1 up at the top there. And you notice all 3 of those are unpaired. That means they can bond or they can match up with electrons from other atoms. And we'll get into that next week when we talk about chemical bonding. So that takes care of aluminum. Okay, so we have 2 more on the next page, sulfur and magnesium. Pause and go ahead and do those on your own before you watch me do it if you haven't been pausing and doing them on your own anyway. I'll give you a second to do that. And we're back. Okay, so I'm going to do both of these silently and see how you did. Okay, so that takes care of that again. Since you know that you have 3 orbitals, the first 2 have to be filled, so you can just fill those in quickly. 2 and then 8, and then you place the valence electrons properly in the 3rd orbital. Okay, now we're going to move down to significant figures. I know this topic bothers a lot of students. It shouldn't. We're going to practice it throughout the year, and the way I generally deal with it on tests is I have you just give a calculator answer. A lot of students aren't comfortable with this big rounding that you do sometimes with significant figures. Give me your calculator answer and then give me the correct significant figure answer, and you get extra credit if you give that correctly. But I will insist that you do some seriously that you do get scored for, because you do need to learn them. They're a part of science. You have to show the precision with which you made your measurement. Okay, so let's get going on this. Let's just read the rules one more time. Anything that's not a 0 is significant. Zeros between non-zero digits are significant. Zeros after non-zero digits are significant if there's a decimal. If there's no decimal, it's said to be ambiguous. That's a fancy word that means uncertain. You're not sure whether they're significant, but we're going to officially treat them as though they are not significant figures if the writer did not put a decimal. Okay, and then finally, zeros before non-zero digits, whether there's a decimal place or not, or decimal or not, they are never, ever significant. I showed you an example of that in class. I'll show that again to make that point clear. Okay, so let's get going. All you got to do is tell me how many there are in each of these. All right, so we got 3 non-zero digits. There's no zeros involved there. That's 3 significant figures. Again, try to do these on your own first and then score yourself. To be a great student, to be a great learner, and I mean not just in school but in life, you got to learn to self-test. Just constantly be testing yourself. It actually makes learning more enjoyable, because you could say, hey, I got them all right, or hey, I didn't. You're actually challenging yourself. So don't just copy. Okay, next one. Okay, so we have 3 non-zero digits, and we have a 0 that's in between 2 non-zero digits. That means all 4 of those are significant. Okay, here we have 2 non-zero digits. We have a 0 in between them. That gives you 3, and the trailing 0 is significant because there's a decimal point there. So that's 4. Okay, 500. You have 1 significant figure. The 2 zeros are ambiguous because there's no decimal point, but we're saying that they are not significant if there's no decimal point. So that's 1 significant figure. Next, 500. It does have a decimal point. That makes everything significant, so that's 3. Next, we have 2 non-zero digits. Those are significant, so that's 2. We have a trailing 0 with a decimal point, so that's a 3rd significant figure. And the 2 zeros out front, it doesn't matter which side of the decimal point they're on, they are not significant. So that's 3. Next one up, we got 3 non-zero digits and a 0 in between 2 non-zero digits, so that's 1, 2, 3, 4. Since there's no decimal point here, we're going to treat these last 2 zeros as not being significant. Again, it is ambiguous. Some books will tell you they're not significant, and there's other books that will tell you it's uncertain. But we're going to treat it as though they're not. Okay? Next one over, we got 3 non-zero digits. We have a decimal, and we have 3 trailing zeros. With the decimal, those trailing zeros are significant. So that's 6 significant figures. Next one, we have 1 non-zero digit that's significant. We have a decimal with 1, 2, 3 trailing zeros. So that's 1, 2, 3, 4 significant figures. All the leading zeros in front of the 1 are not significant. So the answer to that is 4. 40,000. Now that's a comma. Don't let it fool you. And I've mentioned this, that in some countries a comma is equivalent to a decimal point in the United States, but it's not a decimal point. So there's no decimal point in this number. There are 4 trailing zeros, but there's no decimal point. So for our purposes, the only thing that's significant is the 4. So that's a 1 right there. 1 significant figure. And I'm telling you how many significant figures, not what the number should round to or anything. This is it. Okay. All right. 50,000, you do have a decimal point. That makes all of these trailing zeros significant. The comma, again, is irrelevant. So it's 1, 2, 3, 4, 5, 6, 7 significant figures there. Okay, here we have non-zero. We have zeros in between two non-zeros, and we have a trailing zero with a decimal point. So that's 1, 2, 3, 4, 5. The leading zero is never significant, so that's 5. Next one, we argued about this. I don't even remember what the answer was. I'll take anything for an answer here, but I think it is 2. Is that what we said? I don't know. I'm going to put a question mark. I'm never going to ask you that, and I don't think you'll ever come up with it. Okay, next one. Okay, so we have non-zero, zero in between two non-zeros, non-zero, and two trailing zeros with the decimal point. So that's 1, 2, 3, 4, 5. The leading zero is not significant, so that's 5. Okay, and here we have a decimal point, which doesn't really matter in this case. Well, it does, but you have 9, a 0 in between, and an 8, so there's 3. The leading zeros are never significant, so that is 3 significant figures. Okay, now we're going to do some math, additions, subtractions, divisions, multiplications, and let's go ahead and do that. So the rules for multiplication is the answer has as many significant figures as the least multiple can. So this one has 2 significant figures, this one has 3, so your answer can only have 2 significant figures. So go ahead, let's do the calculator answer first. Okay, so that's going to give us 20,178. I'm not going to bother with commas here. Okay, and our answer, though, can only have 2 significant figures. Here we have 5. So only these 2 can be significant. So the way you deal with this second one is you use the digit that comes after it. It's not a significant figure, but you use it for rounding. So since that's a 1, that 0 is going to stay at 0. It's not going to round up to a 1. So the answer there is 20. Okay. Okay, go ahead and do all of these. And again, challenge yourself, test yourself. Leave space, though, for the correct answer if you didn't get it right. Go ahead and do these. Okay, and we're back. So let's go ahead and do the next one. 0.102 times 5.3. Okay, and that gives us a calculator answer of and the least number of significant figures here is 2 right there. Again, that leading 0 is not significant. So that means we can only go to there. And since that next digit's a 0, that 4 is going to stay as a 4. So there is our SigFig answer. So again, on a test, if you gave me this answer as a final answer and it was correct, you'd get full credit. You get a bonus point if you then give me the significant figure answer. Okay, how about this one? We can see that only has 1 significant figure. So our calculator answer is 0.0092, but we can only have 1 significant figure. That would be the 9 right there. So this 2 has to round the 9. And it's going to round it back down to stay as a 9. So the way you write that is 0.009. 1 significant figure. These guys are not significant. Okay, the next one. And this is the type that'll drive you crazy. 890,734 times 4. Okay, and that's going to give you 3,562,936. With a number this large, usually you do put commas in, but we're not here. Okay, because of this, we can only have 1 significant figure. That means only this first digit can be significant, but we have to round it. With a 5, I'm sure you all know the rules of rounding. You're going to round it up, not down. Anything that's 4.99 and below, you round down. Anything that's 5.0 and up, you round up. So you're going to round this up. So that's going to become a 4. But it's not just the number 4. It's got to be something in the range of 3 to 4 million. So it's going to be 4 million. So these are you're going to follow this with zeros, 6 zeros in all. So all of these digits that are not significant turn to zeros. I know it seems strange, but it just has to do with the fact that you didn't make this measurement nearly as precisely as you made this measurement. And therefore, you can't show it. You can't show this level of precision right here. You have to show only this level of precision in your measurement. Okay, let's keep going. Now we have a division problem. The rules are the same for multiplication and division. So it's 8.90 divided by 2.4. And that gives you, it gives you a big long number. So what do? We, it's only going to be 2 significant figures. So if I gave you the calculator answer, it's a big ugly number here. It's a 3.708 followed by repeating 3s, put the little line over it. Okay, but we're only significant to this many places right here, and that 0 is going to keep the 7 as a 7. It's not going to go up to an 8. So our answer is 3.7. Next one, 9.001 divided by 4.02. Okay, and there's 3 significant figures is the least number. That's 4 significant figures. That's 3 significant figures. So our answer is 2.2390. And you really don't have to write this whole thing out here. You just want to give me the number of significant figures. Or sometimes you just truncate it. You cut it off after about the 4th digit because it's ridiculous to write this whole thing out. But we only have 3 significant figures, so it's 2.23. But that 9 is going to round the 3 up to a 4. So it's 2.24. Okay. Okay, now we have 3 operations. It doesn't matter with multiplications and divisions what order you do them in. Commutative property, do them in any order you want. Well, you do have to multiply these 2 and then divide by that. So not quite, but you could do this division first and then multiply. Okay, so let's go ahead and do that whole thing as one big calculation. 6.2 times 8.992 times 5.78 equals, and that gives us this. It's 3. Let me start again. I messed that. It's 322.2373, and there's a couple more digits, but I ran out of space. So we don't need that. We only have 2 significant figures. You have 2 there, you have 4 there, you have 3 there. So 2 is the least number of significant figures. That means the only 2 that are significant are these first 2. This 2 is going to round that 2 to keep it at a 2. It's not going to go up to a 3. So it's 3, 2, and then 0. And we can't put a decimal point there or it will turn that 0 into a significant figure. So it's just 320 without a decimal point there. Okay? All right, do the next one. Okay, and what we get here is 24,047 point this. Okay, that's our calculator answer. How many significant figures? Only one significant figure there because there's no decimal. This one has 3, this one has 3. So this was another one of those that, it makes you a little crazy, but this would be the answer. But this 4 is the only significant figure is at 2. This 4 is going to keep it at a 2. It's not going to round up to a 3. So you've got 20,000 and don't place a decimal. Otherwise, it'll make those zeros significant. Okay. Now we're doing the last three. We're going to do some addition, subtraction, or addition, well, really just addition problems. The rule is entirely different. It's not how many significant figures, it's how many digits after the decimal point. The least number of digits after the decimal point, you will round your answer to that number of digits. So let's go ahead and write this out as, I'll put the bigger number on top. Doesn't matter in addition, it's commutative. Plus 4.76 goes there. You have to line up decimals for addition. And when you add those two numbers, and what you get is, I'm going to put it down below here. So you're going to get 12.745. But you only have two places after the decimal. Here you have three here. So you just draw a line down there. You cut it off right there. Okay? So this is the last significant figure. But you'll notice that the next one is a 5. That's going to round this 4 up to a 5. So don't forget to do the rounding at the end. So your final answer for this, going way out of the box here, but that's okay, 0.75. So that's your final answer for this problem right here. Okay, got that? All right, next one. You have, and it doesn't matter which one goes on top, just be sure the decimals are lined up. You have 45, now it doesn't have a decimal, so you can go ahead and place a decimal there. And then you have 0 decimal lined up, 4, 5, 6. So let's add those two together. So 6, 5, 4, decimal, 5 and 0 is 5, and 4. And there you go, you get 45.456. But there's nothing after the decimal place here, so you draw a line right down like that. Okay, and there you go. These are not a part of the answer, only the 45, but you do use the 4 to round the 5, and since it's below 5, that stays as a 45. So it's funny. It's a funny problem because you started off with a 45 as one of the numbers you added, and you end up with your answer still being 45. Okay. And finally, let's do this one. 3.6589 plus 2.54755. And we add those, we get 5 and 4 and 16 and 10 and 12 and 6. Okay, so we have in our answer 5 digits after the decimal, but one of our add-ins only had 4, these 4. So you draw a line down like that, and this 5 will round this 4 up to a 5. So your final answer is 6.2065. And there you go. Okay, so that's addition, subtraction, multiplication, division. Okay, so let's have some fun here with some longer ones. So you're going to need your order of operations, Pemdas, parentheses, exponents, multiplication, division go together, addition, subtraction go together, Pemdas. So what that means is we're going to group these. So the first two that are going to go together are, all three of these can go in any particular order. This times this divided by this divided by this times this divided by this times this, it doesn't matter, okay? So go ahead and we'll write that out. Okay, we get a really long number. And I'm going to write the whole thing out. 7.00 Okay, you get that long number, but what you keep track of at this point, you don't round anything in the middle of the problem. You do all of your rounding at the end. Very important to remember. Unless it's a super long number, and here's what you can look at. We see that we have two significant figures there. That means our answer can't have more than two significant figures. Period. It just can't. So, but you're not going to round here, but you don't necessarily have to write this whole number as long as you can see that that's not, it's not going to be anywhere near that number of significant figures. Okay. So now we've taken care of the multiplication division. We're now going to go ahead and write this out, do our addition subtractions. You do these together. So you could do this subtraction first and then take that number and add it to this, or you can add these two numbers first and then subtract this. Again, subtraction is not commutative. You can't switch those two around, but you can do this in any order, okay? Let's just do it in the order that it's put there. So I have that big number plus and I end up with this. Now I'm going to do a step that I really don't need to do, but I'm just going to do it just to demonstrate it. If I wanted to round addition subtraction, I would look at the least number of digits after the decimal. And here you have a whole bunch. Here you have 3, and here you have 4. So 3 would be the least number of digits after the decimal. So that means I'd round this to 3 digits after the decimal. So that would give me 13.75, and that 4 will round the 8 back down to an 8, so it'll stay at 8. Okay, so that's the rounding just of this addition subtraction. But remember, we kept track of our significant figures from this part, and we only had 2. So we knew it wasn't going to be this as our final answer. So we only have 2 significant figures in our answer. It's those 2 right there. This rounds the 3, the 7 rounds the 3 up to a 4. So the answer is 14. Okay, so study that one if that seems a little confusing. Just do Pemdas. Keep track of your significant figures, but don't round anything until the very end of the problem. Okay, go ahead, pause, do the last one. And we're back. Okay, so what do we have here? We have a multiplication right here. So let's go ahead and do that. And you see that there's only 2 significant figures there. So this is going to give us 7.062, and then the other 2 numbers, we'll go ahead and just write them in here. Okay, so now we just have additions and subtractions. So we see, we're going to circle this because it tells us we're 2 significant figures at most. Let's go ahead and add all these together. And what we get there is 6.508. Again, just to do it as an exercise, there's 3 digits after the decimal, there's 2, and there's 2. So we can only have 2 digits after the decimal. So that's going to be these 2 right here. So all 3 of these numbers will be part of the answer. But this 8 is going to round this 0 up to a 1. So you have 6.51. So right now we're sitting on 3 significant figures there. But up here we saw that this was going to limit it to 2. So that means it can only be these 2 right here. So that's going to be 6.5. And I am off screen, sorry about that. So 6.5. And There you go. That's your final answer to two significant figures. So again, these solutions videos, you don't have to watch the whole video. Just skip around, find the problems you need help on. You don't want to listen to me talk, just shut off the sound. Remember, you can always rewind things, watch the solution a second, third time. So, really try to figure these things out from these videos, but if you can't, that's what we have class time for. So anyway, that's the assignment for the weekend, for the Labor Day weekend. We'll see you on Tuesday. Have a great weekend.